12 planks. That's all 2 men with a pit saw could manage in a brutal day if they survived the ordeal below splintering logs. Then came a force stronger than muscle, the river itself. Water-powered sawmills didn't just split timber, they split open a new era for America and forever changed the meaning of risk and reward. What did it take to harness living water, and why did so many men pay the price for progress? Rivers never tire. While men collapsed from exhaustion at the end of a pit saw, water kept moving, day and night, season after season. Communities surrounded by endless forests faced a simple limit: human strength. A team of sawyers could wrestle a dozen planks from a log in a day, but only at the cost of blistered hands, aching backs, and hours lost to fatigue. Water changed that equation. Harnessing the steady push of a river meant replacing muscle with something relentless. The current could turn a wheel, spin a shaft, and drive a saw blade through timber hour after hour without pause. The difference was staggering. Instead of weeks to cut a trunk, a mill powered by water could slice through dozens in the same time. Where men's bodies failed, the river delivered. This was more than a boost in output. It was the first step toward true mechanical power. Water was not just a force of nature. It became the engine behind the lumber that built towns, ships, and the bones of a growing nation. A pit saw team worked in the shadow of the log, 2 men bound by sweat and rhythm. The top man, called the top sawyer, balanced above on the timber, gripping the upper handle of a whipsaw. Each downward pull demanded every ounce of his strength, muscles straining as the teeth bit into green oak or pine. Beneath him, the pitman stood in a trench, sometimes lined with elm to keep out the damp, staring up at a ceiling of bark and sawdust. His job was to haul the saw upward, fighting gravity, then to pause and scoop out the choking dust that clogged the cut. The saw itself was a brutal tool, as long as a man is tall, with teeth designed to cut in both directions. The log was pinned in place with iron dogs or wooden blocks, but even so, it could shift or bind the blade, sending a shock through the arms of both men. They worked in a slow, relentless cadence, back and forth, hour after hour, stopping only to sharpen the saw or clear the kerf with a bucket. On a good day, a seasoned pair might wrestle 12 boards from a single log. Every plank was paid for in blisters, aching backs, and the ever-present risk of injury. This was the grind that fueled the earliest building booms, a world where wood was won by pure endurance, and the promise of something easier hung just out of reach. Long before sawmills dotted American rivers, a remarkable leap in engineering took place on the edge of the Roman Empire. In the ancient city of Hierapolis, now in modern-day Turkey, a stone sarcophagus bears silent witness to a breakthrough that would echo through centuries. The relief carved on the tomb of Marcus Aurelius Ammianus, a local miller, shows more than just pride in his craft. It reveals the earliest known machine to turn the endless spin of a water wheel into the back-and-forth bite of a saw. Water from a mill race turned a wheel, which drove a gear train. That motion spun a crank, and a connecting rod translated the wheel's rotation into the straight, rhythmic push and pull needed to slice through stone. 2 frame saws worked at once, powered not by muscle but by the river's steady flow. Ammiano's design did not just save sweat. It proved that water could be harnessed to do what hands alone never could. The principle was simple, but the impact was profound. By mastering the conversion from rotary to reciprocating motion, this ancient mill set the pattern for every water-powered sawmill that followed. Its genius lay in making the river itself a tireless worker, laying the groundwork for centuries of mechanical innovation. A river's power is nothing without control. Early millwrights faced the challenge of turning an unpredictable current into a steady, reliable force. The solution began with the dam, a wall of earth, stone, or timber built across the stream to raise the water level and create what they called head. This head was not just a measure of height, it was stored energy waiting to be released. Behind the dam, a reservoir formed, holding back enough water to keep the mill running even when the river ran low in late summer. From the pond, water was channeled into the mill race, a carefully dug trench or wooden trough that carried the flow right to the mill. The mill race narrowed as it approached the wheel, speeding up the water and focusing its force. At the end, a sluice gate acted as a simple but effective throttle. By lifting or lowering the gate, a miller could control exactly how much water hit the wheel, adjusting for the day's needs or the season's mood swings. Every decision mattered. Too little head and the wheel would barely turn. Too much, and the dam might burst, flooding the valley and destroying the mill. The shape of the mill race, the height of the dam, even the angle of the sluice, all were chosen with care, balancing power against risk. These choices set the stage for everything that happened next, as water left the race and struck the waiting wheel, ready to be transformed into motion. Rivers shaped the choices of early millwrights, dictating which water wheel would turn logs into lumber. 3 main designs emerged, each tailored to the river's speed and drop: undershot, breastshot, and overshot. Undershot wheels sat low, letting swift water push beneath their paddles. They worked best on wide, shallow streams with steady flow but little elevation, spinning fast, but delivering only modest torque, enough for lighter tasks. Their efficiency hovered between 20 and 30%, making them a practical fit where speed mattered more than strength. Breastshot wheels met rivers that offered a bit more drop. Water struck these wheels at mid-height, blending the force of the current with the weight of falling water. This design boosted efficiency to 50 to 70%, producing steadier, stronger torque for heavier sawmill loads. In regions with moderate streams and rolling hills, breastshot wheels became the workhorses of 18th and 19th century industry. Overshot wheels required the most dramatic landscape, a high head often created by damming and channeling water above the wheel. Water poured over the top, turning the wheel by gravity's pull. With efficiencies reaching up to 85%, these wheels delivered powerful, slow-turning force, perfect for the largest saw frames. Where hills and valleys allowed, overshot wheels transformed every foot of drop into mechanical advantage, making the most of every drop of water. Each site demanded its own solution, matching river to ambition and laying the groundwork for the machinery inside. Inside the mill house, the river's strength travels through a hidden network of wood and iron. The main shaft, spun by the water wheel outside, turns with a steady, patient force. From this single axis, a series of gears, some as wide as a wagon wheel and with teeth worn smooth by years of use, pick up the motion. Each gear meshes with the next, adjusting speed and torque, setting the rhythm for everything that follows. The millwright, sleeves rolled and hands blackened with grease, listens for the first hint of a rattle or grind. A tooth out of line or a shaft running dry could throw the whole system into chaos. At the heart of the power train, the main gear's rotation is captured by a crank. This crank, pinned to the shaft, transforms the smooth spin into a push and pull back and forth again and again. A stout iron rod, called the pitman arm, connects the crank to the saw frame above. With every turn, the rod lifts the heavy sash and then drops it, driving the blade through timber in a relentless vertical stroke. The gear ratios are chosen with care. Too fast and the saw bucks and binds, too slow and production crawls. Most mills settle on 40 to 60 strokes per minute, a balance that slices through green oak without tearing the teeth from the blade. Every moving part demands constant attention. The millwright walks the length of the shaft, feeling for heat, checking the fit of wooden bearings, tightening iron collars. A single loose pin or a cracked gear could halt the operation. leaving logs stacked and men idle. In these moments, the true genius of the system reveals itself, not just in brute force, but in the delicate harmony of motion, where water's endless flow becomes the measured heartbeat of the saw. A fresh log waits at the mill's threshold, its bark slick with river water, sap still weeping from the cut. The crew gathers around, boots sinking into sawdust, their movements practiced but wary. Every man knows the risks that come with the first cut. The log cart, a stout wooden sled riding iron rails, carries the trunk forward, inch by inch, toward the hungry saw frame. Two men work the handspike, steadying the load as it rolls off the cart and onto the carriage. Iron dogs clamp it in place, but the round wood resists, threatening to twist or shift at the worst moment. A millwright checks the alignment, eyes tracing a chalk line along the log's length. This is the reference face, the first, truest cut that will guide every board to follow. If the log binds or shifts, the saw can jam, the blade can snap, or the entire frame can shudder off track. The sash saw, its blade tensioned in a tall wooden frame, waits above. The pitman arm begins its slow dance, rising and falling with each turn of the water wheel outside. The saw's teeth hover just above the bark, poised to bite. With a nod from the foreman, the sluice gate is opened. Water surges through the race. The wheel turns and the gears catch. The sash jerks to life, blade plunging down in a steady rhythmic stroke. The first teeth meet the log with a groan, sawdust spraying from the kerf. Men brace themselves, watching for the slightest movement. If the log rolls or the blade binds, someone could lose a hand, or worse. Each pass of the saw is a test of balance and nerve, a silent conversation between wood, steel, and water. In this moment, the mill becomes a living thing, every worker tuned to its pulse, every action weighed against the promise and peril of that first cut. Inside the mill, the promise of water power came with a grim price. The machinery ran without pause, and so did the risks. Every exposed belt, every spinning shaft, every reciprocating blade was a hazard waiting in plain sight. The air throbbed with the racket of iron and wood, drowning out shouted warnings, grinding down the senses. Sawdust hung heavy, coating lungs and skin, while the floor stayed slick with water and sap. Workers labored in the constant noise, day after day, their ears ringing long after the wheel stopped. Logs weighing a ton or more rolled off carts, sometimes shifting without warning. A single misstep could mean a crushed foot or a broken leg. The first cuts were the most dangerous. If the log twisted free of its clamps, it could pin a man against the carriage or send him tumbling toward the blade. The sash saw, moving up and down 40 times a minute, offered no forgiveness. Hands, arms, even whole limbs were lost in an instant to the hungry teeth. Leather belts, stretched tight between pulleys, snapped without warning, lashing out with enough force to break bones. Injury was woven into the daily routine. Amputations were common, and there was little hope for recovery. Men worked with missing fingers, stiff joints, or deep scars that never healed. The dust and damp brought their own slow toll, coughs that lingered, eyes that stung, backs that bent before their time. In the relentless drive for production, the line between progress and peril grew thin. Each board that left the mill carried the hidden cost of flesh and blood. By the mid-1800s, water-powered sawmills stood at the height of their influence. Across North America and Europe, tens of thousands of mills transformed entire forests into beams, planks, and masts. Shipyards along the Atlantic coast demanded white pine for schooners and warships, while towns rising inland needed endless boards for houses, barns, and bridges. In New England alone, more than 5,500 sawmills operated by 1840, each one fueled by the steady force of a local stream. Connecticut counted nearly 700. The United States, stretching westward, boasted over 31,000 sawmills, almost all of them drawing power from water. This era of abundance was driven by the relentless cycle of water and wood. Mills ran day and night during high water seasons, their production outpacing anything hand labor could hope to match. Lumber that once took a team of sawyers weeks to cut now rolled out in hours. The output fed industries beyond construction, supplying furniture makers, barrel factories, and wagon builders. The very shape of settlement followed the rivers, as towns clustered around mill ponds and the promise of steady work. But the same rivers that brought prosperity also set hard limits. Spring floods could sweep away dams and wheelhouses, while summer droughts left wheels idle in the mud. Every mill depended on the moods of the watershed. As demand soared, these constraints grew more costly. Steam engines, first introduced after the Civil War, offered a solution. Unlike water wheels, steam could run anywhere, in any season, untethered from the river's rise and fall. By the late 1800s, steam-powered mills began to outpace their water-driven rivals, operating year-round and closer to the expanding railroads. The decline was gradual, not sudden. Some water-powered mills lingered into the early 20th century, especially in remote valleys or where water was plentiful and cheap. But as technology advanced, the days of the river-driven sawmill faded. The age of water power had crested, swept aside by the promise of steam, and soon after, electricity. What remained was a legacy of innovation, industry, and a landscape forever changed by the meeting of wood and water. Water-powered sawmills didn't just change how wood was cut. They reshaped entire communities and set the stage for the world of industry that followed. The river-driven mill was more than a machine. It was an early experiment in automation. Inside, each worker found a specialized role. Sawyers managed blades and carriages, millwrights tuned gears and shafts, and laborers hauled logs and cleared debris. This division of labor, once foreign to rural economies, became the blueprint for factories and assembly lines that would later define the industrial age. Towns grew up along streams not by accident, but by necessity. The promise of steady work and reliable power drew families to the banks of every creek with enough drop to turn a wheel. Streets took their names from vanished mill ponds, and the rhythm of the saw set the pace for daily life. The mill was often the heart of the settlement, grinding grain, sawing lumber, and sometimes even running wool carders or cider presses from the same shaft. Economic maps of the early United States reveal a pattern. Prosperity clustered wherever water could be bent to human will. The bones of this era still stand in places like the Garland Mill in New Hampshire. Built in 1856 and listed on the National Register of Historic Places, Garland Mill remains a working example of 19th-century ingenuity. Its water-powered sash saw still slices through logs each spring, run by the same dam and mill race that once powered the dreams of earlier generations. Here, visitors can watch the gears turn, the sash rise and fall, and the old division of labor play out in real time, a living reminder that before electricity, it was the river that set everything in motion. The legacy of these mills lives on in modern industry, in the flow of work from one station to the next, in the relentless pursuit of efficiency, and in the idea that communities can be built and sustained by harnessing the power of nature. Even as most water-driven mills have vanished, their influence endures in every automated line and every town that grew up beside a stream. The legacy of water-powered sawmills still echoes in every automated process that shapes our world today. As industry races forward, the same drive to harness new forces, once water, now data, reshapes labor, risk, and progress. The line between invention and consequence remains as sharp as ever. Every advance carries its own cost. If you found this story illuminating, subscribe for more journeys into the machinery behind modern life.